In question 9, the diagram shows a prism, and the cross-section of the prism has exactly one line of symmetry, and we need to work out the volume of this prism. Okay, so I've actually drawn in the line of symmetry as a blue dotted line, and this means that the triangle at the top of the prism is isosceles, so 40 degrees is one of the other base angles, and actually, since the dotted line is a line of symmetry, it splits the base into two 5 centimeter lengths. Okay, so we can start by doing the following. We can actually work out the perpendicular height of the triangle at the top of the prism. If I let h represent the opposite side, then 5 centimeters is the adjacent, and we also have the hypotenuse and a 40-degree angle. Now, since we know the length of the adjacent and we're looking for the opposite, we can use TOA in SOHCAHTOA. The tan of the angle equals the opposite divided by the adjacent. So here, the tan of 40 degrees equals h over 5, and therefore h equals 5 tan 40 degrees, which is 4.195, and so on. So, we can now work out the triangular part of the cross-section. The area of a triangle is a half times the base times the perpendicular height. Now remember, the base length of the triangle is actually 10 centimeters. So that's a half times 10 times 4.195, which is 20.977. That's the area in centimetres squared of the triangular part of the cross-section. Now the other part of the cross-section is the rectangle. That's 12 times 10. So that means that the area of the complete cross-section is 12 times 10 plus 20.977, which is 140.977 centimetres squared. Now the volume of a prism is the area of the cross-section times the depth. So that's 140.977 times 20, and this equals to three significant figures, 2,820 cubic centimetres.